Hello everyone, hope you can hear me. My name is Ionut Craciunescu. I'm an engineering manager at Utility Warehouse, and this talk is going to be about our journey into data as a product and how the first iteration went for us so far. First things first, though, as I said, I'm an engineering manager. I'm not on the direct delivery path for the things I'm going to talk about. These are being built by a group of awesome people, so thanks to them for the great work they are doing. The reason for me being here is that some of them are abroad and they can't be here in person, so there you go, you got stuck with me. Few things about Utility Warehouse, if you haven't heard about us. We are a multi-service provider, trusted by more than 800,000 customers. It's fully regulated, and what we do is sell utilities, things like energy, broadband, mobile, and insurance in a single bill, so you can save money on things that matter to you. We have a head office in London, UK. Most people are based in the UK, but we have plenty of people throughout Europe, in places like Romania, Spain, Italy, and we have people as far away as South Africa, Brazil, Canada, or Australia. Without necessarily being remote first, we call this being remote friendly, and it allows us to hire worldwide through some partner companies. This talk will be split in three parts. First part, why data is a product and what does it mean? Then an introduction to data mesh. Has anyone heard about data mesh before? Few people at the back, great, thank you. And then I'll try and do a small tech demo, hope it doesn't blow out, so fingers crossed. Right, so why data as a product? I'm pretty sure most of you heard about data as an asset mantra, which would mean hoard your data, keep it there, hope it will increase in value in time. If that would be true, then data value will grow in time by simply storing it, which we know it's not the case. So an improved mantra, at least from my point of view, is data as a product, which is simply applying product thinking to both analytical and operational data, such that data sets, they have a bunch of capabilities, like being easy to discover them, they are secure, I can explore data sets, find out about them, and easily understand what structures exist in there and build my dashboard so I can take data-informed decisions. This is with a goal to unlock the value of the data, as some people call it, or simply put, get better at taking data-informed decisions. And we all know Netflixes and AWSs and how they go about that, but for those that watched the movie Moneyball, it's about a baseball coach which used what later got known as sabermetrics to improve team composition and went on and won 20 games in a row, if I'm not mistaken. Now, moving from stories, let's say, to real-life-ish or tech stuff, most of the times there's a scenario like this one, where there's a bunch of applications, each one has its own database, maybe there's a data warehouse in there, a big data platform, but loads of data pipelines, and they all look like spaghetti, and it's very difficult to manage these and keep them under control. Besides this, the way things are organized most of the times these days is common to have a bunch of sources to ingest on one side, get that data into a big data platform, and then you have some consumers on the other side. The thing is, the data in the platform, in the big data platform, belongs to different domains and is being generated by a bunch of domain-oriented teams or product teams or service teams, depending how these are called in your organization. At the other end of the spectrum, there's a different type of domain-oriented consumer teams, maybe product people, maybe sales, maybe marketing, that have a need to consume this data in forms of dashboards, analytics, KPIs, in order to get better decisions supported by data. In the middle, there's a group of people which is not so happy, and most of the times these are the data engineers and machine learning engineers, and this is the group of people where people go to and say, hey, give me my KPIs, give me my analytics, what's the relation between this data set and that data set? This thing happened on the graph. What does it mean? Well, I don't know. Let me go to my software engineers because they build that data and they own it. And if you forgot already, the tech landscape that data engineers have to operate in is similar to this one. Okay, so what do we do next? Well, enter data mesh. Data mesh is a concept, and one of them is about, instead of having a central data team, migrate to have the data engineers, data analysts embedded in the cross-functional teams, work alongside them. It's very common these days to have platform engineers embedded in the team working with them. And by having these data engineers embedded in the domain teams, it enables them or it helps them to own the data not just for the application but also operational data, and treat that as another product they care about and they create alongside the primary application they develop. Why is it called a mesh? Well, it's a concept. It's about the end result where this whole thing tries to get us to a space where there's data sets published by all the domain teams. They're discoverable, it's easy to understand them, and it's easy to correlate data across domains. Taking the example of utility warehouse, we sell electricity, we sell gas, we sell mobile, we sell insurance, all under a single bill. How do we correlate the data across these all domains? Well, we think data mesh is the data mesh approach will enable us to achieve that by providing the domain teams the tools necessary to treat your analytical data as a product. If you are interested about extra material on this topic, I highly recommend this talk by Chris Ricomini. It's not data mesh related, but he gives his opinion about the evolution of data engineering. He talks about the similar concepts and similar approach to what data mesh tries to do. Data mesh was a thing coined by Jamak Degani. I hope I pronounced her name correctly. Apologies if I didn't. When she published a post on ThoughtWorks blog, 2019. And datamesharchitecture.com website is super useful. There's few diagrams in there and does a very good job at explaining the concepts of data mesh and how to get there. Right, so what did we do at Utility Warehouse? Well, we understood that we have a challenge to do cross-domain data analytics. We started doing a bit of research. We learned about the evolution of data engineering. We've come across the data mesh concept, and then we tried to figure out, okay, how do we get there? What do we need to do? How does it work for us? We started building internal awareness around it, and we proposed a solution. We've identified a first use case, decided whether we need a team or not to work on this, and we quickly said, yes, we need a team because it's a well-defined problem space. The team at the moment is called Data Infra, or Data Infrastructure, or Data Infra in short. The team started doing some research, proof of concepts, they built some internal tools, and then they iterated and improved the architecture. We also spent some part of the Data Infra team. We spend a lot of time with our users, and our direct users are data engineers and software engineers. And we also work alongside them to raise internal awareness and do tech demos. We use some open source internally. We started using something called Bentos to help with data extraction because we didn't want it to get in long-term contracts with any other company. We wanted to learn first and experiment with as small cost as possible. And there's many more things to come ahead of us. What is the current team focus? Well, we have some sources to ingest on one side, like spreadsheets, SFTP inputs, Postgres databases, custom-built applications, Kafka clusters. And when I get that data into Google BigQuery, we make use of GCP, AWS, and we also have a private data center, but the data landscape sits in GCP, and BigQuery is a very good warehouse, fully managed for us. So I get that data in Parquet format in Google BigQuery, such that data engineers can use Dataform to remodel it in new formats suitable for analytics, and expose it in a dashboard on Looker, Looker being our BI tool at the moment. Data Infra team currently is focused on lowering barrier to entry when it comes to publishing data as a product, and I'll show you in a minute a data product definition or schema file, which is just a YAML, pretty simple, and solving problems of how do I extract and load data from Kafka, for example, and load it into BigQuery. We have highly autonomous teams, and many of them, they solve this problem already, but when you go and speak with them, they have slightly different implementations. So we try to bring some standardization, and then there's additional things that we want to build on top of that. Quick intro about the tech application. This is a bird's eye view, very simplistic, oversimplified. Most of our applications, they have a React UI, GraphQL API. They talk with the backend through gRPC using protobuf. Most of data sits in Kafka clusters, and we make use of event sourcing patterns quite a lot. Some data does end up from Kafka into a relational database where we have well-identified use cases. In terms of tech stack architecture, the things we've done in data infra, we've created some sources that run on a cron schedule. So that's iteration 1. That's how we started. We made use of bentos in some cases where we had to extract data from some custom applications. And that data is being sent to Google storage in buckets. Then an event is being triggered and the connector kicks in and grabs that data, sends it to BigQuery. And we've also built some automation, a Git repo with YAML files for the data products definitions. I will show you those in a minute. We quickly realized this is going to be a problem, as in sending data directly to Google storage is going to be a problem with authentication and authorization. Managing storage, managing keys for many buckets is going to be a challenge. And in V2, we've decided to introduce an API. The role of the API is to do authentication and authorization for the sources on the left side. It's also exposing a bunch of useful metrics for us that we display on Grafana dashboards, for example, or in traces soon. And it's also doing data validation. We validate data on the consumer side, but we also validate it on the server side. As data hits the API inspects that data and checks, does it match my data definition, the schema that is being published in Git? Yes or no? If yes, then it's being sent to Google storage. Now I'm going to switch to a quick demo. Hopefully it doesn't break. Fingers crossed. So I've spun up a bunch of containers locally using Docker Compose. You can see, for example, this one is called Kafka source. The level of logging in here is set to debug for 2 reasons, because it's demo, and it's very useful when people develop tools to have a good understanding of what's going on. I also have a UI for Kafka. I have a Kafka cluster locally, and if you see here, I hope you can see it at the back, there's 0 messages at the moment. And I'll show you BigQuery in a moment. We've also built a CLI tool called AIO, for better or for worse, which is an acronym for all-in-one. I know it's not the greatest, we're going to improve it at some point. And like any CLI tool, it has a help. Oops, scrolling too fast. And I can do things like AIO list DPDs, and it will give me a bunch of data product IDs. And by the way, data product, because I was jumping the gun to the CLI, this is how it looks. It has an ID to uniquely identify data sets among each other, a bunch of description, versioning, an egress section to tell us where the data is going to end up. And the important part is the data points array, which has entries for each attribute type. There's also support for nested attributes where I need to. So these files are the ones that end up in a Git repo. And basically this YAML file is what software engineers, they have to create to help them publishing their data as a product. It's being stored and versioned in Git, and the API uses these files when it does data validation. Earlier on, when I've run AIO list DPDs, the AIO command communicated with the API and said, give me a list of all data product IDs. And because all of this is meant for machine-to-machine communication, at the moment, I only get IDs. Probably we're going to add some human-readable names in the future. I can also do things like AIO DPD and give it an ID. And in return, I get a JSON output of the schema. So this is one YAML file that I have on a local machine, but this is what the API is aware of. So I can compare what's on my machine, what I want to do, and what the API has. Besides that, there's additional things like I can write to Kafka cluster when I'm developing my software. That's pretty straightforward. AIO Kafka put, Kafka cluster address, test is the topic name, and this is a protobuf file. Press enter, it's going to take a bit of time. And if I go to Kafka, I should have 1 message count in there. And I can also now verify that it's in BigQuery. So before I go to BigQuery though, I have a message in Kafka, and what happens? Now using the CLI tool, I wrote a message to Kafka. This is being picked up by the Kafka source. the message is being sent to the API. API will do validation. Validation passes, ends up on Google storage. Once it's being written to Google storage, the API fires an event, ends up into an internal Kafka cluster used by the data infra team. And those events are consumed by a BigQuery connector. And the BigQuery connector will grab the files from Google storage and write them into BigQuery table. Going back to the table, this is the table. You can see the schema in here. I can expand, for example, nested attributes, amount, value, currency, and validate those with my YAML file in here. And I'm going to have to do a refresh to see my new event. Okay, actually, I need to go to preview. There's a bunch of events in there from previous attempts. You might notice there's a timestamp column. That's the timestamp from the protobuf file. So as data is being written, it's application specific. It's not a timestamp of when this particular row has been written to BigQuery. They are all the same because I'm writing the same event. We decided to use Unix timestamps, and we stored those in a column called UW batch because we grab data from Kafka in batches. We can control the amount of messages, the amount of time the connector waits for it, and the amount of data in terms of megabytes or kilobytes. Check this one. So a minute ago, that's my data in there. The team is also working on adding tracing to all of these, so I can see traces end-to-end from the Kafka source to the BigQuery connector and help me with my troubleshooting. And those should be available in a Jaeger UI. If I go Kafka source, find traces, there they are. And I can observing here all the operations from a Kafka source, which is reading from the topics and things with the API, interactions with the API. I can notice most of the time has been spent writing to BigQuery. That's the end of the tech demo. Hope it was useful to ask questions if you have any. Right, so did we face any challenges so far? Well, there's always challenges. One of them is that engineers are busy with day-to-day delivery. The things that we do in data infra, they have to solve actual problems for software engineers, not make their life more difficult. For example, if a team already solved loading data into Kafka, if our tools, they are not compelling enough, they will never be used. Data as a product and data mesh is still a new, and it takes time to get there. There's some new tools to learn, some tools that we wrote in-house. There's some internal training that needs to happen. Generally speaking, the tooling around data mesh is not quite there yet. If I'm to refer to, let's say, data catalogs, we haven't settled yet on a product. And besides that, there's another mindset shift which is needed. One of them is around data ownership, and that is about product teams or domain teams own data for analytical data as well, not just operational data. And you might have heard things like DataOps. If you remember back in the day, we have developers and operations working in silos. We realized, oh, that's not good. DevOps came about. For some reason, data has been left behind, and part of the DataOps is similar to what DevOps tries to do. It borrows from the same principles. It's a long journey ahead. At the moment, each team at Utility Warehouse can analyze their own data. We do try to bring standardization in there when at the tech level, but there's still challenges on analyzing cross-domain data. It's going to be a while to get there. For example, there's many more things to be done, like policy automation. Once you get that data into a place, how do you know who has access to it? How do you know it should have access? How do you monitor your pipelines? And how do you do data quality? For example, if you have a data source that's loading currencies like pounds, and you have a negative number, then that's a data quality issue. It's things that we are yet to solve. Getting close to the end of my talk, like many other companies, we are hiring. Do go to our careers website, have a look at LinkedIn. A job role which is dear to me because I'm looking after the team. This team is software engineer for developer enablement. It's a new team that started recently, and this is aimed at solving common problems across software engineers, helping them being better at the things they do. This is the end of my talk. Thank you for listening.